Hello folks, hello YouTubers and friends. This is the second video on my cold steam turbine. I've never done this before, ever. Okay, it was just a theory that studied over the years. We've got a vacuum in here, and the water right now, I have a laser thermometer, is I don't know if you can see that, 77 degrees. Okay, so at 77 degrees, water, machine, every daggone thing, and a vacuum. We've got a cooler thing on the top. I'm going to show you what's going to happen. We're going to light the press the light torch and set it under it. There it goes. Now if you had that much water at 77 degrees, put it in a pot on the stove, it would take, it's already boiling already. It would take a lot longer than that to boil. But the thing is, as the heat builds, it'll start to boil even more. The reason for that is because I've got a slight leak in my gaskets. This particular apparatus was, I built it simply to do a few tests with, to make sure and to show people what I'm talking about, that you can get water to boil at below 212 degrees, already 97 degrees. But anyway, I've got a leak in there, so I don't have a completely perfect vacuum. You can see it's boiling like crazy. So like I said, this is a temporary build, mainly for testing and so forth, so I'm having to use gaskets here rather than use some kind of high temperature silicone or whatever, and a permanent seal. With a permanent seal it would work a lot better. Right now I'm using a combination neoprene and cork gasket, and it's, like I said, it's getting a heck of a leak in it. But I've got to be able to take it apart so I can put different apparatuses in to test and so forth. And oh, by the way, this thing is going to take a cooling system that's so big, it's unbelievable by comparison to the boiler itself. In messing with it, you can see how it's boiling right now. Crazy, man. Crazy. But anyway, what was I going to say? Oh yeah, the cooling system is going to have to be really huge. It dawned on me that when you use high pressure steam, of course the temperature goes way up. But when you put, say, like for example, 500 or 600 degree steam under pressure in a cooling coil to cool it off, you've got that steam under pressure. You got a lot of molecules that are extremely hot touching cold surface. Where with the cold steam turbine, you're using a vacuum, so there's much more distance between the molecules. So therefore, it's going to take a much larger cooling system. However, because it's a vacuum and not high pressure steam, a cooling system can be built a lot cheaper, a whole lot cheaper. For what it would cost to build a cooling system for a high pressure steam system, you could probably build one 4 or 5 times as large for the same price, which is about what you would need too. It's going to be that much difficult. Oh man, she's really going to town now. Check it out, folks. Check it out. Alright, I'm going to end this clip because I'm going to have to take this apart, and I can't find a gasket for it, so I'm going to have to get a neoprene, some silicone, and make my own gasket. I'll go to the auto store and get some high temperature silicone. They can make a high temperature silicone that'll take 600 degrees, but this thing will never get much over 200, if that high. Like I said, cold steam. I'm going to try to do this thing at steam at about 140, absolutely no more than 150. I don't want to get it really hot. That's the whole point of the cold steam. Any steam below the normal 212 sea level boiling temperature, but use the steam to push water, not the turbine. Use the steam to push the water to push the turbine. Okay, folks, y'all have a good afternoon, and I'll see you in a day or so. Okay, folks, we're back. In the last clip, I showed you that I had this apparatus set up here, right up here. Let's see. I've got a vacuum valve, air conditioning valve that I hook my vacuum pump to. But anyway, we pulled the vacuum on this, and we threw some heat on the bottom, and the water started to boil at like 77, 80 degrees, something of that nature. Basically to prove that water will boil at less than 212 degrees. Okay, I get a little confused sometimes. Anyway, the problem we have here, situation, is that the gaskets we got, they're good. They're great gaskets. Nothing against naphtha auto parts where I bought them. It's just that they're great for oil, water, and gas, but not for air. Okay, so we need a better gasket. So what we're going to do is we're going to try to see if we can't make our own gaskets, because I've looked around. I cannot find a gasket to do what I want, the size that I need. So what we've got here is we've got some plexiglass, and we have a 5-inch cup saw or hole saw. And I watched a video of another guy that did something. He did it with a cup saw. A funny comment. One of the comments was by some gentleman that said, "Hey, am I the only person in the world that doesn't have a hole saw set?" Okay, for you, sir, and for all you other people out there, here is a 12 hole saw set. It's a 16 piece. Of course, you've got 12 different size hole saws, and 2 arbors. One is a 3/8 arbor, the other one is a 1/4 inch arbor. And I got this at Northern Industrial Tool for $10. Can you believe that? 12 different size holes for $10. Anyway, make a long story short, the largest size in here is a 3.5. Okay, so my deal up here is roughly 4 inches outside, so that's going to be big enough for my inside. And the 5-inch, of course, it is much bigger than it'll cut a hole 5 inches in diameter, but the inside is going to be smaller. But anyway, what I'm going to do is I'm going to cut a couple of pieces of this, and I'm going to cut a 5-inch hole in it. Then I'm going to take the 3.5 and cut the piece that comes out. I'm going to cut a 3.5 inch hole in it, which it will be about 3 3/8 to 3 7/16. That should give me the inside. I'll put the big piece and the little piece on here, okay, and then put I'm going to go to auto part store and get some high temperature silicone. It's safe to use up to 600 degrees. So, and this will go nowhere near that. Regular silicone would probably work, but I'm just going to play the safety factor. And what we're going to do is put them down in such a manner. I'll show a short clip of that. I'm not going to show clips of me cutting the holes, because everybody already knows how to use a hole saw. So again, I don't like to bore anybody. But once I get it together, then I'm going to show it together and how I'm going to do it, and put the silicone in it, wipe it off smooth, and then let it set. Now, to keep the silicone from sticking to the plexiglass, what the heck did I do with that stuff? Oh, there it is. We're going to use hand soap. I have used this several times in the past. Just pure hand soap, no water. I've used it in the past to keep silicone from sticking to objects, and it seems to work very, very well. In fact, if you put silicone down on something and it's a little bit rough, you can squirt a little liquid soap on it and just smooth it around with your hand, and I mean make it come out slicker than glass. So actually that's about what we're going to do. We're going to coat a solid piece with liquid hand soap. Then there are 2 other pieces. We're going to coat them with hand soap, both sides, and now you'll see why. Put them down in place, fasten them down. Now, I'm not sure exactly how I'm going to fasten it down. I like using magnets, so I'll probably put it on a piece of steel and put some magnets around it to hold the pieces in place. Fill the gap with silicone, then squirt a little bit more hand soap on it, and take a straight edge of some kind, maybe even another piece of plexiglass, and scrape across it so the top is slick. Then let it set. Now, if it works, great, and I'll show you that it works. If it does not work, I will also show you that it didn't work so that you don't waste your time doing it, okay? Alright, I've used hand soap with silicone many times in the past, and it's always worked, always. But there's always that one time it doesn't, and if it doesn't, we need to figure out why, and you need to know. Okay, alright, enough for this clip. Let me take care of this, and I'll make another clip that'll show you the results. Okay, folks, I said that I was going to try not to bore anybody with things that they've already seen, already know how to do, but I've run across a neat little trick that I learned a few months back trying to cut, use a hole saw to cut MDF board. When you use a hole saw to cut an MDF board, what happens is it heats up, the glue melts, and causes the sawdust to get lodged in the teeth. And of course, unlike steel, you can't put cutting oil on it. That was going to ruin your MDF board. So what I come up with is it's like air conditioning. You take your air compressor, you pump it all the way up as much as it'll go, and then you just wait for the tank to cool off. Well, when you pump it up, of course, you already know that you're compressing the heat that's in the air that you put it in there. So if you let it cool off, the air that comes out is cooler than the ambient air outside. And that's what I've done. Fortunately, I've got a large tank. I've got over 80-gallon tank, and I've just pumped it up to about 120 psi. And now it's just, you know, room temperature to the touch. So the air coming out should be fairly cool and keep the acrylic plexiglass from melting. However, I do have chips that are seemingly glued together, so I'm going to have to cut very slow and use quite a bit of air. The cut itself seems to be very clean, so I'm going to make a little cut. Like I said, I don't want to bore anybody. Oh, by the way, I do a lot of metal drilling, but in saw cutting a hole and drilling. And if you're going to use glue or paint or anything like that, if you take an air compressor coil, go to the junkyard and get one, like out of a window unit, and place it close to your drill press, put it inside of an insulated metal box, fill it full of water and ice, and then hook your air compressor to one side of it, and then the other, that's going to give you a lot colder air that comes out of your spray nozzle. And the colder the air, the better. I mean, that's what cutting oil does. It keeps the metal cold. A lot of people say it lubricates it. Well, you don't want lubrication. There's places where friction hurts you, and there's places where it helps you. And drilling a hole, you don't want to get rid of the friction. Trust me. So oil is not the best solution. It is the most common solution, yes, but it's not the best solution. Best solution is really super cold air. Two things. Number one, obviously, it blows all the shavings and chips out of the way, and number two, it cools your metal or your material that you're actually cutting. So I just wanted to bring that to everybody's attention, and I'm not even going to fire it up. I mean, you can see the hole. It's very neat. And like I said, I don't want to bore anybody with things that other people have already done 267 times. So enough for that. Okay, anyway, it's a tip. Bye. One other point I'd like to bring up when you're using a hole saw or cup saw to cut a hole in soft materials that heat up fast. When you, like right now, I'm waiting, my compressor turned on, so there's no point in going anymore. It's just going to be pumping more hot air into the air. So I stopped just long enough to let the compressor go, build up, turn off, and then wait for the tank to cool down. During that time period is not wasted. Bring your saw up and check and make sure that there's no teeth with melted or glued up materials binding up the teeth. Any tooth, any section of tooth that gets lodged up with material in it, is all it's going to do is not going to cut. It's just going to heat up your parent material and cause it to melt, and that you don't want. So I'm using my fingers. That's not a good idea. Best idea would be to use one of those small toothbrush looking things, like a wire brush, but it's brass. That way you can clean your daggone teeth while you're waiting for your compressor to cool down, and just turn it around and brush in the direction that the teeth go to cut. Okay, so in other words, you want to brush like this. I'm doing like that, but what you want to do is turn it in the opposite direction and brush your teeth and get all the gunk out of them. Here's another thing too. The less you cut and bring it back up and cool the teeth and the material, the better off you're going to be. To cut a good, neat hole is not a quick and that's it. You're not going to do that. You cut plastic or composite woods like MDF or OSB board or anything with a lot of glue in it, you're going to have a lot of problems if you try to horse it. Don't horse it. If you want to burn it through, get you a burning kit and burn it. But keep your teeth clean and take your time. If it's worth doing, it's worth doing well.